Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about logic gates. Today we're going to be talking about all the various types of logic gates. Okay, so we have your computer, right? But how does a computer work? Inside, there are these things, there are these little switches called transistors, okay? And inside these transistors, there are these switches, okay? Each switch turns on and off. Computer scientists say that switches that are on can be represented as 1, and switches that are off represent as 0. And eventually, a string of these ones and zeros eventually creates something called binary, which is the language of computers, which allow computers to, do its stuff. But how does it all work? Okay, today we're going to be looking at the basic form of computer logic. Okay, we're going to be talking about logic gates. Okay, so we're going to be talking about how computers process these. Okay, because the thing is, computers, okay, each of these bits, okay, these switches contain, each single one contains a bit, okay, which is information. But the thing is, computers don't store these bits, they process it. A computer takes it in, inputs into outputs, and puts out a result. This is the main foundation of logic gates. So let's look at each logic gate. The first one is a NOT gate, okay? So for example, we put in a 0 into a NOT gate, which is represented by this symbol, we would get a 1, okay? So this basically reverses it, the opposite. So this is a truth table, which will show all the results. So if you put in a 1, then the NOT gate will give out a 0, okay? That's the first type of logic gate, the NOT gate. The second type of the logic gates is the AND gate. Okay, maybe computers need to process more to get more complex things. So maybe some gates have to process 2 bits. This is where the AND gate comes in. Let's say these 2 bits, okay, are A and B. Okay, how the AND gate works is, let's say A and B were both 0, then the AND gate would process it as 0. If A was 1 and B was 0, it would output 0. If, let's say, B was 1 and A was 0, it would still be 0. The AND gate only outputs a 1 if both A and B are 1, okay? Now, again, there's also another version of this, okay, which is called the third type of logic gate is the OR gate, okay? So basically what the OR gate here, represented by this symbol, if you put in 1 and 0, you process it through, it gives you 1, okay? So as we see on the table, A and B, if they were 0, 0, it would output 0. If you input 0, 1, it would be 1. If you input 1, 0, it would be 1, and if you put 1, 1, it would output 1, okay? Now, with these 3, right, we can combine each one of these gates to create complex stuff. For example, let's say you have these 2 bits, 1 and 1, process it through an AND gate, and you process it through a NOT gate, you would get 0, right? Well, for this complex, this complex design coding, this is also a gate, okay? This is a NAND gate, okay, which is basically an and a NOT gate combined, which creates this symbol, okay? It's basically an AND gate with the dot in front, okay? So a NAND gate is, like I said, a combination of both, okay? And as we see on its truth table, if it was 0, 0, it would output 1. If it was 0, 1, it would output 1. If it was 1, 0, it would output 1. If it was 1, 1, it would output 0. okay? Now, let's go to the fifth one, which is the opposite of this, kind of, okay? Which is the NOR gate. It's the opposite of the OR gate, which is a combination of OR, the OR gate, and the NOT gate, okay? It's basically the OR gate with a dot on the top, on the front of it. So if we processed two zeros, it would output 1. If we processed 1 0, then it would be 0, 0 1, 0, and 1 1 0, since it's the same as the OR gate and the NOT gate. So it inputs this and the NOT gate switches it, okay? Now with just all of this, we can create complex machines. For example, let's say we have this puzzle over here, okay? Let's try to, well, solve it. So in this simple puzzle, there are these two bits, A and B, which are both 0. We have to make sure that A or B turns out to be a 1. But the thing is, A and B cannot be 1. Both of them cannot be 1. So we have to create some logic gates in order to, get a 1, okay? So let's say, okay, let's process A and B to maybe a NAND, okay? Maybe we can process it out, and if we put 0 0 on a NAND, it would process 1, right? Now let's say we process these, okay, and it's 0 0. So what can we use for that? 0. So if we use an OR gate, it won't work. An AND gate, though, 0 0 also doesn't work. So let's see. For example, another NAND gate, okay? So we can also put it like this, okay? This would be processed into an AND gate, which would then be processed into a NOT gate, okay? Which would turn out, okay, how about we put this somewhere else on the board, because it's a bit hard. So let's say, right, this is the puzzle, 0 0. We have to figure out, okay? We put these forward. We put an AND gate. We put this forward into a NOT gate, okay? And this would process us 1, okay? 0 0 on the AND gate would output into the NOT gate into a 1, okay? But both cannot be 1, because that would just create it into 1, okay? So then we would take these out, okay? These are two different ways, okay? Or we could simply, we could put it as something else. So 0 0, right? So for 0 0, A and B, so for an AND gate, that won't work. For an OR gate, 0 0 will also output a 0, okay? So it would technically be a NAND gate, okay? So it's kind of like the same thing. And then we would input these two, okay, into as a 1 1, okay? So this is also 1, this is also 1, and then we can process these into a regular AND gate to get us 1, okay? But this is all just, a bit too complex. And there is a gate to, fix all of this stuff. It's a special type of gate called a XOR, okay? Which is the sixth type of logic gate. It's a very specific type, which is basically all of that. So if it was 1 and 0, so if one of the two bits is 1 and the other one is 0, then it would output at 1. The same would be said on the other side. 1 is 0, and so hence on and forth. But if it's double, like 2 1s and 2 zeros, it would cancel out, okay? So it would cancel out. This is what the XOR bit gate does, okay? I might have not explained this solution properly, but it's one way, okay? And of course, there is an opposite version, okay? It's a NAR, Okay, and what the NAR is well, czar, what, okay, whatever, the X is silent, and it goes by this symbol, okay, and it's basically the opposite of it. So any two of the same digits will become the opposite of it. Okay, well, the same, well, one. For example, two zeros will make one, 0 1 will make 0, 1 0 will make 0, 1 1 makes 1. Okay, and these all are the more common types of logic gates, which are again the basic form of computer logic. Okay, so that's basically what logic gates are. And well, that's basically it. Thank you for watching this video and hope to see you next time. Bye bye.